हेलो स्टूडेंट्स, आज की क्लास में हम रिमेनिंग डाउट सॉल्व करने जा रहे हैं। तो द फर्स्ट डाउट वी आर गोइंग टू टेक इज H7 dipole moment of the given molecules are such that, so we have three examples. Let's take BF3, F3, F3, like this. F, F, all these bond polarities, all the three bonds are polar, but the polarities are going away from the atomic 20. Molecule is triangular planar, triangular planar. The beauty that these all bond cancel out their polarities, going to be zero. Now if we compare NF3 and NF, these both molecules are pyramidal in structure, rather pyramidal. Now एक्सपेक्टेशन ये है कि NF3 के अंदर 3 फ्लोरीन और फ्लोरीन की इलेक्ट्रोनेगेटिविटी हाईएस्ट होती है, तो ये मॉलिक्यूल की कंपैरिजन में ज़्यादा पोलर होना चाहिए, लेकिन होता इससे बिल्कुल अपोजिट है। क्यों? क्योंकि तीनों बॉन्ड की पोलैरिटी गोइंग अवे फ्रॉम सेंट्रल एटम्स, तो ऑल टुगेदर बॉन्ड पोलैरिटी गोइंग अवे फ्रॉम सेंट्रल एटम एंड द लोन पेयर पोलैरिटी opposite direction. So altogether, this polarity cancels out each other, and due to that, net will be definitely non-zero. It will have some value, and will definitely non-zero. While in case of Na3, nitrogen has higher electronegativity as compared to hydrogen, so bonding electron attracted towards nitrogen. So these three bond polarity towards the nitrogen, and the polarity of lone pair is also in the same direction. So all together molecule highly polar. So and in is also non-zero, but the polarity of these Na3 more. Why? Because three bonds polarity or dipole moment and the dipole of the lone pair are in the same direction, while in case of the dipole moment of these three NF bond and the dipole of this lone pair are in opposite direction, cancelling each. So lowest will be of BF3, highest will be of NH3. So it should be highest, then NF3 is B. Question. The correct order of dipole moment is, now you have CH4, that is non-polar at 0. Now just now we have discussed NF3 and NH3. NH3 has higher polarity, and definitely H2O is even more polar than OH. OH. Electronegativity of oxygen is definitely more than that of nitrogen. The bonding electron pairs are towards oxygen. Oxygen highly polar. Definitely electron pair, lone pairs are also in the same direction. So altogether polarity of H2O is, so methane less than NF3 less than NH3 less than, first option is the correct answer. Which of the following cannot be completely hydrolyzed in cold water at room? Now for hydrolysis, this we will discuss in detail when we will study organic. For hydrolysis requires requires presence of orbitals at central. Now we will focus on BCl3, BR3. As such, they have sp2 hybridization. Due to that, they have empty paired orbital. Focus on to the BCl3 definitely has sp ionization, but it has a empty 3 orbital and Cl4. Of course, chlorine has empty orbital, but carbon does not have because it has sp hybridization element of second period. So carbon does not have hydrolysis. What happens? Hydrolysis H2O molecule attacks as a nucleophile and is lone pair of electron of oxygen donated in empty orbital for that empty orbital should be available. So BCl3 and Br3 has empty that orbital available. BCl3 has empty 3D available, but carbon does not have empty any orbital in second period, does not have empty d orbital also. Why? Because its principal quantum number 2. Of course, at higher temperature is hydrolysis possible, that we will discuss in organic chemistry. The answer will be C. H13, which is the true statement about SiH3 tries. So this is called trisilyl. The trisilyl amine is better word. Trisilyl. Now, what is there in this? Nitrogen is there as or sorry, it has complete filled sp3 hybrid orbital. SiH. This is SiH. So central atom has what? Central atom has completely filled as silicon orbital. So what happens in this case is back bonding. Due to that back bonding, this nitrogen does not have nitrogen available for donation. तो इसका स्टेरिक नंबर भी निकालना चाहे तो निकाल सकते हैं। अटैच्ड एटम्स और उसके पास अब एलपी इट इज प्लस 0 now assume an expected hybridization sp now its shape is triplanar. Let's check the option. It is trigonal planar. It is trigonal pyramidal. Stronger Lewis base. ट्राइगोनल पिरामिडल तो नहीं रहा वो। अगर अगर ये अमोनिया होता या तो ये ऐसा होता एन थ्री थ्री, तो यहाँ पर ट्राइगोनल पिरामिडल स्ट्रक्चर होता। तो यहाँ पर बैक बॉन्ड, यहाँ पर बैक बॉन्ड और बैक बॉन्डिंग नहीं है, तो यहाँ पर इसकी इलेक्ट्रॉन पेयर अवेलेबल है। That electron pair can be donated. So this is good Lewis base as compared to this. Why? Because this has nitrogen. Lone pair is consumed or utilizing back bonding with orbital of 3. So it is stronger Lewis base than CH3 thrice and wrong. Why? Because electron pair is not available. It has a total 9 sigma bonds. It is also wrong. Why? Because SiH3 is SiH3, SiHHH. So these itself has 3 sigma bonds, 3 sigma bonds, 3 total 9 sigma bonds, 10, 11, 12. So actually it has got 12 sigma bonds. So this is also wrong. And it is trigonal planar, actually triangular planar should be the word. So answer is why? Because it has assumed sp2 hybridization. So it has turned to triangular planar geometry. Next question. Among the following molecules, the dipole-dipole attraction does not play most important role in the melting point and boiling point. Means what? Dipole-dipole attraction should not take place. Means what? The molecule should be non-polar. Non-polar. ICl. Now, electronegativity of chlorine is more, so bonding electron pairing is attracted more towards chlorine, making chlorine minus delta and iodine plus delta. So it is polar. Br2, this is non-polar, check it. Why? Because both the atoms are bromine. So bonding electron pair will not attracted to any of these bromine atoms. So both bromine will not carry charge, so this is non-polar. Now H2S, electronegativity of sulfur is more as compared to that of hydrogen. So both hydrogen will be partially positively charged and sulfur will be partially carbon monoxide. It is like this. So as compared to carbon, oxygen has higher electronegativity. Oxygen will carry partial negative charge and carbon will carry partial positive charge. And due to that reason, this is also polar. So this is polar, this is polar, this is polar, and Br2 only is non-polar. So as it is non-polar, there is no dipole-dipole attraction. Answer is going to be Br2. And in this case, what is important is going to be London force. लंदन फोर्स या तो आप कह सकते हैं डिस्पर्जन फोर्स. The dispersion force is responsible for its content. Okay. At ordinary temperature and pressure among halogens, chlorine is a gas, bromine is a liquid, and iodine is a solid. This is because of what? Cl2, R2, I2. Why chlorine is gas? Because of intermolecular force of attraction in case of chlorine must be lowest. Bromine is liquid. In that bromine, the intermolecular force of attraction is higher, and in iodine it should be even higher than that, right? So chlorine to bromine and bromine to iodine attractive forces should be order, and that is what going down the group. Down the group, what happens? Down the group, size increases, size per rather size increase, surface area of contact per of to all these factors you can van der Waals force in. So chlorine being smallest in size, surface area is minimum, number of electrons also minimum, so forces of attraction that of iodine size is largest, so surface area of contact will be also large, and number of electrons will also be maximum out of this. So van der Waals force of attraction will also be very high. I think the answer is very clear. Intermolecular forces among the molecules of Cl2 are the weakest and those of iodine strongest. Okay, which molecule is the London dispersion force likely to be most important in finding the boiling point of the student? Br2. Which of the following is false? Van der Waals forces are responsible for the formation of molecular crystal. Branching lowers the boiling points of isomeric organic compounds due to reduction in the van der Waals force of attraction. In graphite, van der Waals forces act between the carbon layers, and boiling point of ammonia is greater than SbA3. Out of these four is correct. Means this statement is wrong because the boiling point of ammonia is lower than that of SbA3. This will because in detail when for the hydrogen bond. Right now we are pending, but we can discuss these. Van der Waals force are responsible for formation of molecular crystal. Why? Because as the van der Waals van der Waals force increases, substance changes from what? Substance from gas to liquid and liquid solid. This we have already discussed in states of matter also. Branching lowers the boiling point. Let's take one example that let's have CH3. This is pentane, and let me take a neopentane. This neopentane, you understand, thus molecule has smaller and it has more branches, and due to that reason, what happens in distance due to branches is so intermolecular distance. This is linear like this, right? This is linear. So more contextual surface area, while this is now spherical like molecule. So I think you know that in here the surface area is found minimum. So contextual surface area will be the attraction is why because distance increases. So the attractive force decreases. So you can say there's branching to branching surface area of contact decrease. So decreases. Altogether statement is correct. And graphite, you must be know that graphite exists such layer form. Hexagonal layers are there. Such hexagonal layer or sheet-like structure might exist. There are several sheets arrayed over. There is no single bond formation of the consecutive. So what exists is to the force of van der Waals force, and due to that, if you apply force parallel to this sheet, this layer can be slided over each. That reason why it is that reason why it is soft, can be used as liquid. Of course, you cannot shift any of the carbon from the other carbon. Why? Because they are connected with by a strong sp overlapping. But the carbon atoms between two layers are connected only by van der Waals force of it. That van der Waals force is very weak. If you apply force parallel to this sheet, that can slide it over each other. Why is strong? Sorry, soft. Diamond in diamond that does not. Diamond is very hard, and as it is soft and less lubricant. So I hope all these questions help you so much for the class. Wish you all the best for upcoming exam. Keep learning, enjoy chemistry.